All right, everyone. Time for our next set of Module 3 notes. Go ahead and start by putting your name and number up in the corner, please, as we always do. Again, this is Module 3, although not for much longer. We're getting pretty close to the end of Module 3 here. In fact, this, zoom in a little bit. Lighting's kind of funny on the video today, so we'll do the best we can with that. Okay. Module 3 notes. This is going to be Module 3, Lesson 14. The title is kind of a mouthful. We are going to practice ways to strategize. Strategize. Whew. We're going to try to find good strategies, good ways to solve multi-term problems. We're going to strategize to solve multi-term problems. Okay. This is, again, Lesson 14, so we need 10, and then one less than 5, so XIV. And got a very good question about where the Roman numerals came from, why they look so much like these letters. Something we probably want to research. But again, mostly just coming from the fact that you can make them with very simple straight lines, although that doesn't hold true as you start getting into bigger numbers. You start seeing C's and things. Anyway, not on today's agenda. Today, we need to start with some vocabulary. This vocabulary is hopefully familiar. We've talked about it in class. We've done the multiplication versions, but I don't think we've written down the addition ones. Okay. So let's start by talking about the commutative property of addition. If you are familiar with the word commute, to travel, usually to work, that's where this is coming from. We're moving things around. I'm going to do something a little unusual. Sorry, let me back up. Normally we go to our subheading, capital A, our subheading, which is just a 1 or a 2 or whatever. We can actually go one level further. So a subheading, I guess. We're going to use A again, but this time we'll use a lowercase a. And we're going to use this to define the commutative property of addition. Commutative property of addition says you can, break your pencil, there we go, you can add numbers. You can add numbers in any order. You can add numbers in any order, and the sum will stay the same. So if I give you something, and we'll do sub. I'm going to stop doing that every time. We're going to do a little b. If I give you 12 plus 3, everybody should know what that is, I hope. Okay. These two numbers here, the technical term for them is addends. Fancy. These two addends we add together, and the answer is 15. That's our sum. Now, we know that works. Hopefully that's pretty easy. However, I have other options. I can also add 3 plus 12. My addends are exactly the same. However, I have moved them around. They have commuted. They have moved. Okay. My addends are the same. All I did was change the order. Most of you are hopefully calling out to your computer, we already know that's the same. It is the same sum. You are correct. Okay. Commutative property says you can add numbers in any order, and the sum, the final answer, will be the same. Now, we're going to back out to our second vocabulary word, number 2, and we are going to talk about the associative property of addition. Now, the associative property is very closely related, and if you remember the multiplication version of this, you probably know how it's going to go. Okay. The associative property says you can change the grouping pairs. You can change the grouping, the pairs of numbers, and the sum will stay the same. The sum will stay the same. Okay? Kind of going off the page a little bit there. You can change the grouping or pairs of numbers and the sum will stay the same. Now, if you're wondering, what's the difference? I've got the same pair of numbers here, 12 and 3, 3 and 12. All I did was switch the order around. The associative property is saying something different. The associative property is saying if I have, let's say, 5 plus 2 plus 3, I can start by grouping these two. 5 plus 2. That's 7 plus 3 more equals 10. Okay, no problem. However, as mentioned previously, I have other options. I'll keep the numbers in the exact same order. 5, 2, 3. But this time, let's group these together. 2 plus 3 is 5. 5 plus 5 is 10. Okay, so not a big surprise there. And the fun continues into the margin. This time I will use the commutative property. I'll move the order around a little bit. 5 plus 3 plus 2. And the reason I'm doing that is because now I grouped 5 with 2. I left 5 by itself. Now I'm going to group 5 and 3 together. 5 plus 3 is 8, plus the 2 equals 10. Whew. We're definitely pushing the margin there. Okay. All of those are the same. All I did was move things around or pair them up differently. And this is going to be very important because we are going to use these two properties today as we move forward with our procedure. So we're going to go to back to B, procedure. Now, what we're going to be seeing today is just kind of a way to use your knowledge of fractions to take a mental shortcut when we're adding or subtracting. It's kind of a smarter way of combining the numbers. You can still do exactly what we have been practicing all of this time. You just add them up, subtract them out, whatever you need to do. But if you can wrap your head around the commutative and associative properties, there is a little way you can take a shortcut. Step number 1. Look for common denominators. Look for common denominators and combine them. Pair them up, basically. Let's say I give you something that looks like this. 3 and 1/6 minus 3/4 plus 5/6. Oh no, there's 3 terms. What do we do? You can handle that. And you could handle it exactly like we've done before. Write these two vertically, 3 1/6 minus 3/4, subtract out, get an answer. Whatever that answer is, add it to 5/6, get a new answer. Check and see if that answer needs to be simplified. But there's an easier way. Look for common denominators. I've got 6, I've got 6. I am going to rewrite this problem. I am going to switch things around so that those two are next to each other. Now this is the commutative property to start. Commutative property says I can change the order. So I'm going to write 3 1/6 plus 5/6. Now, if you're looking at the subtraction and thinking, wait a second, we didn't say anything about... Subtraction order is very important. And that's why we are going to make sure that this subtraction symbol stays with the fraction that came after it. We are still subtracting 3/4. Those two are like a package deal. You keep them together while you're moving things around. Subtracting it here, subtract it there. Subtraction's real picky, so you have to be careful. I think it's really easier to focus on we're moving the addition pieces around and leaving the subtraction exactly the same, but however you want to wrap your head around it. Now, as we prepare for step 2, I'm going to draw parentheses around these two because I'm going to use the associative property to say I want to add the terms with the same denominator first. Step 2. For step number 2, if, and you will see that this is not always possible, it will be today, but not always, if you can complete a whole, if you can make a whole set, do that first. Sometimes you can, sometimes you can't. But if it's possible, do that first. Then, or if you can't do that, just jump straight to this part, add fractions / mixed numbers, whatever you have. Whatever you have, go ahead and add the fractions, mixed numbers, whatever, with common denominators. Take those ones with the common denominators and put them together. Combine them, add them. Common denominators together. Now, after I wrote this, I realized probably could change that add or subtract, but it's usually going to be addition. So I'll leave it for now. All right. 3 1/6 plus 5/6. We already paired these together because they have the common denominator. We are going to subtract 3/4 from it eventually. Looking at these, look at just the fraction part. 1/6, 5/6. If I put 1 and 5 together, that's 6. These two fractions together create one whole. They make one whole. That is awesome. So what I'm going to do, let's put our equal sign there. What I'm going to do is bump over here 1/6 and 5/6 combined to make one whole. The 3 is still here, it didn't go anywhere. But now the fractions have come together to make a whole. Now you probably notice I ended up combining the numbers or the fractions with the same denominator as part of that. But if I had maybe plus 1/4 or something over here, I would do that at this step as well. Okay, minus 3/4. Now finally, to wrap up, for step 3, step number 3, whatever's left, just solve and simplify. Again, you might not always be able to simplify, but if you can, do so. Now we're out of paper, so we're not going to spend a ton of time lining everything up. And again, the idea is hopefully you don't really have to. This first part in parentheses doesn't get a whole lot easier than that. Subtracting the 3/4 might take a little bit of brain power, but we're up to the challenge. 3 plus 1 is 4. Okay. Minus 3/4. So 4, one last broken pencil for the road, I guess. 4 minus 3/4. I can do the vertical subtraction, but I can also just look at this and count up 3/4. I would need one more fourth to get up to a whole number. 1/4 gets me up to 1. Then from 1 to 4, 1, 2, 3, 4, I would need 3 more whole numbers. So after all of this, my answer is 3 and 1/4. Okay. Now again, there are different ways to do this. You could line it up vertically and subtract out the way we've been practicing, but I think this works pretty well too. We will practice both in class. As always, if you have any questions, write them down so we can discuss. But that's going to be it for this particular lesson. All right. Thank you, folks. I will see you soon.